Okay, so visualization technique is of course an interesting topic in data science. Okay, so instead of having a very huge table of data, by exploring the data, okay, many times we will explore the data in two terms. Okay, two ways we will explore. Number one is we'll explore using programs. Okay, there are many statistical functions available. We'll calculate the mean, average, as we did now. We just sorted, we just rearrange it, we ascend it, we descend it. So using some functions, we can understand the data set. The very important second method is using visualizing. Okay, so usually whenever a complex problem is given to us, okay, so people say, to understand the complex problem, first you draw it. Okay, then you will understand that complex problem. That is what is the feedback of many experts. The same case here also. First, we draw the data set and we'll understand what is that data set is. So here we are going to discuss about the various visualization technique. There are many visualization techniques available in the Python, in the data science, using many libraries. Okay, so matplotlib is one library and cburn is another library. There are many libraries available to do it. Okay, but the five important plots that everybody of us should know is line plot, bar plot, histogram, box plot, then scatter plot. All right, so one by one we will discuss what is that every plot and where do we use those plot, all those things. The number one is the line plot. Okay, whenever you want to just visualize continuous data. Okay, for example, ECG signal of a patient. All right, so the patient may be at home, right, and a small ECG sensor is attached to his body. Now, the doctor want to monitor that particular patient from the hospital. All right, if there is any abnormality, you want to monitor from the hospital. In that case, he can just stream his ECG signal and it can be drawn as a line plot in the doctor's monitor. So if suppose there is a small down, okay, there is a small depth in the ECG or small glitches in the ECG, he can understand, okay, something is wrong for the patient. So immediately he can give a remote prescription to that patient. So whenever your data is continuous, in that case, we go for line plot. Okay. So here is an example. We are going to experiment first. We are going to, in general, do all the plottings. Okay. Use for a general data set that we generate, we will do it. And then we are going to do all the plots for the data sets, various data sets. Okay. Now here you see we generate X. Okay. Then we did y is equal to sin x, and the syntax for that is used to do a line plot is py plot. What is a py plot? Py plot is the function in the matplotlib library. Okay, matplotlib is the important library used for data visualization, and py plot is a function that is used. Okay, py plot dot plot of x comma y. Okay, then to show it, we will use py plot dot show of the function. Okay, so you will get a output like this. Okay, so can you see here on the right side, you will get an output which is a continuous sine wave. All right, so you would have discussed, you know, enough about the sine wave in your mathematics. This is about the line plot. So what is the next plot? Bar plot. Okay, so where do we use bar plot? Whenever there is a categorical data. Okay, so what is categorical data? We discussed what is categorical data in the first session itself. What is categorical data? Age. Okay, so age is a category. How many people are in the age group of 30? How many people are in the age group of 40? Okay, how many people are in the age group of 50? There is no continuity between 30, 40 and 50. It is all discrete. Okay, so how many people have visited the mall today? How many people have visited the mall yesterday? Okay, what is the number of sales today? What is the number of sales of car yesterday? So this is how the categorical data is. So here we see we just generate three categories: red, green, blue. Okay, so for that red, green, blue, we also generate Y. Okay, so we say random from 0 to 100, again random from 0 to 100, and random from 0 to 100. Three categories, and for those three categories, we generate random data. Then we just do pyplot.bar. Okay, I want everybody to remember the functions, every function. Okay, you may be given a scenario, then you will be asked for this scenario, what is that function you will use. So questions like this may appear for your exam. Okay, So now we say that dot bar of xy. So you get a bar plot like this. Now, how many red you have, how many green you have, how many blue you have. That is what is the output of the bar chart. Now, similar to the bar chart, there is one more data for continuous variable. Okay, so what is that continuous variable value? Histogram. Okay, now histogram is one very, very important visualization tool used in data science. Okay, so now it is used to summarize the distribution of the data sample. Okay, so for continuous data, we will use it. Okay, so from -3 to whenever your x should be of continuous. Okay, so -3 to -2, how many data? Okay, then -2 to -1, what is the total number of how many values are there? Okay, then what about this? And what about the skewness of the data? You see that the data is little bit of dissimilar. Here you have -3 and -3. Okay, it is little bit of skewed towards the left. More data are there in the left than in the right. Okay, so that is what is the observation you can get from the histogram. Okay, so what is the difference between histogram and the bar plot? You may get a question, ma'am. Bar plot is also some box. Okay, it is showing some vertical box. Histogram is also showing some vertical box. Okay, so what is the difference between a histogram and the bar is? Bar chart is specifically meant for categorical data. Histogram is specifically meant for quantitative data. Okay, and bar chart, I'll show you the difference here. Okay, here. And the bar chart is where you will have discrete events. You will not have any continuity between the first category, second category, and the third category. But in histogram, you will have continuity between the categories. Okay, so now in the very important point is the bar can be rearranged. You can even plot blue, green, red. Okay, for example, I'll show you one example of COVID data. Okay, I'll show you one screenshot of this one. Okay, this is one visualization, that is map. Okay, again in data science, it is a very important visualization tool, that is map. We will discuss that in later. Now here you see the bar. Okay, so it says that June 30, what is the number of affected people? May 31 and July 30, July 31, June 30. Okay, every month end is shown here, but in between it's shown all these data. Okay, suppose I want to plot in descending order, I can do it. Okay, but histogram, you cannot rearrange it. That is what is the difference between histogram and the bar plot. Okay, number one, histograms are used to show the distribution, while bar plot are used to compare the variables. Number two, histogram is meant for quantitative and bar chart is meant for categorical. Then bars can be reordered, but the histogram cannot do it. So this is about the bar plot and the histogram. The next very important plot is the box plot. Okay, so box plot, we would have seen a plot like this. All right, what all the information? So box plot gives us lot of information about the data. What information you get? What is the minimum value in the data set? What is the maximum value in the data set? What is the middle of the data set? Okay, so from the minimum, what is the 25% of value? So from the minimum, what is the 50% of value? So from the median, what is the 20? Here is 25, here is 25. Okay, so 25% of value. That is what is called lower quartile, upper quartile. So it gives us all these information. From the box plot, you can observe all these information. Not only that, there is many importance of box plot. Okay, number one is you can get the minimum value, maximum value, and median. The distribution of your data set can be observed using the bar plot. Okay, the minimum value, maximum value, and then the median. Okay, then the second one you could see here. All right, the skewness. What is the skewness? More number of median is here. All right, but more data is there beyond the median. Okay, beyond the median of the value, there are more number of data is recorded. All right, here what you say, before the median, more data is recorded. All right, that is what is the skewness. So here you see that more data is there towards the right of the observation. That is later on in your observation, more number of data is recorded. Then later on, but before it, more data is recorded. For example, let us take the box plot to display the number of patient visiting the hospital. Okay, and I decide that the median is 12 o'clock. Okay, I decide that the median time is 12 o'clock. So here this positive skew says that after 12 o'clock more patient are visited. Here the negative skew says that before 12 o'clock more patient has visited. Okay, and the normal distribution says that even it is equal. The total number of patients visited a hospital is equal. So this is how we can observe using the box plot. Not only that, you can also check out outliers. Okay, if any of the data samples is too large, for example, the total number of patient visited a hospital may be 100 per day. Okay, if it is a multi-specialty hospital, it may be 100 per day. Suppose the data recorded, it says 10,000 per day. Okay, it is really an outlier value. It is an abnormal value that is recorded. Okay, or it is a multi-specialty hospital, but it says that the number of patient visited is 0 per day. Then again, it will fall under this outlier category. If it says 10,000, this fall under this outlier category. Now, all these can be recorded in the box plot. Okay, we'll do that by experimenting a particular function. Okay, shortly. Now, this is can be observed by the box plot. In addition to that, you can also compare it. Okay, compare it means today's box plot with yesterday's box plot. Okay, today's box plot with next week Monday box plot. Okay, now you can just draw an conclusion about what is the trend on Monday. Okay, if the every comparison says it's equal, you can just explain about the trend of patients visiting on Monday, or trend of people visiting a mall on Monday. Okay, on Friday. So every Monday, the trend of people visiting a mall is less. Okay, so on every Fridays and Saturdays, it is high. So you can draw a conclusion or summary of your data set in that way. Okay, so this is an use of a box plot or a whisker plot. All right. Next one, this is an example code that I have given. Okay, we will all do it. We are just doing 3 categories of data. We are plotting for 3 categories of data. Can you see that there are 2 circles? So these circles says that these are all outliers. So this is a minimum value in the data set. This is a maximum value. The median value is just 0. Okay, and then here you see that these 2 categories, all these 3 categories, the median value is same. Okay, and the number of observation in the first category is very less, but here it is little bit high, and this is very big high. So all these we will be discussing. We will experiment this shortly. Okay, the next plot is the scatter plot. Okay, now I just want to know what is the distribution of my data set. Okay, whether it is confined from 0 to 100. This is yet another plot which you can just check out the distribution. Okay, or I want to see whether everybody belong to the same category or a different category. Okay, so what I do is I just plot them in a scatter plot. Okay, let me take for example, I just perform a survey. Okay, so survey on do people like online classes? Okay, do people like online classes? Then what happened? You will say yes or no. Okay, there are how many categories may be there? There may be yes category, there may be no category, then there may be category that no comments. Okay, some category will say no comments. Okay, so there may be 3 category of people. Now I want to just check out what about the categories. Okay, I just want to plot out the scattering of those categories. Okay, then I do a scatter plot. Okay, in 3 colors. I can do it in 3 colors. Okay, so the X plot may be the age. Okay, 40, maybe let's start with 10. Okay, 10, 20, 30, 40, 50, 60, 70. And I just do a scatter plot. Okay, then a red color for yes, red green color for yes, red color for no, and blue color for maybe or no comments. Now when I plot it here in the scatter plot, I will understand what about the population count of people who dislike the online classes, or what about the where is the people grouped. Okay, where is the category of people who really like the online classes, who really don't like the online classes. So the scatter plot help you to understand the relationship between two categories, two or three data samples. Okay.